Here we'll try to find out surface area of the sphere. So we don't have any lateral surface here, so it's just the surface area. Even curved surface, it's just the curved surface, but there is no total surface. Doesn't have any flat surfaces anywhere, so it's just the surface area, total surface area, the entire surface area of the sphere. So before we start off with the diagram, let's understand one of the famous Archimedes hat box theorem. So what it says is, if I take any section of the sphere, its lateral surface is equals to the lateral surface of the cylinder of the same height with the same radius of the sphere. So let's just take this as my radius r. So if I actually cut sections, so because it's a sphere, so curved surface, so which is actually going to be, those are my sections, these are my sections. If I cut the sphere into sections, there are many sections, you can make any number of sections. So let's just take one section out of it, any one. So if I take that section, lateral surface area including that and going one round, lateral surface area of that is actually going to be equals to lateral surface area of a cylinder, LSA of a cylinder, with the radius of the sphere, that radius and that radius, same radius, and this height is actually going to be equals to that height, So even if I take that, it's still the same cylinder of same radius, although my diagram is not exactly similar, but you get the idea. So radius is, that is the radius, height is, that is my height, that's my height. So lateral surface of that particular section is equals to lateral surface area of cylinder with the same height and the radius of the sphere. So keep that in mind. So now if I take this as a whole, so that means full surface area should be equals to a cylinder of same radius as the sphere and the same height as the sphere. So if I'm actually going to take a sphere and a cylinder, height is same for both of them, and the radius is actually going to be same thing I've drawn here. So if they are same, this sphere is actually supposed to fit exactly inside the cylinder. So this sphere is touching the top and the bottom and also the sides of the cylinder. What happens here? So if I consider the height of the cylinder is actually this portion, which is r plus r. Height of the cylinder is actually going to be 2r. Getting back to Hatbox theorem, it said lateral surface area of a particular section, now here I'm going to take the entire sphere, is actually equals to lateral surface area of cylinder of same radius and same height, whereas our height is 2 times radius. So if I'm going to take this lateral surface area is just the surface area of sphere. This is 2 pi r, lateral surface area is 2 pi r h. If I substitute h with 2r, 2 pi r into 2r, it's going to be 2 into 2, 4 pi r square. If you see, this is actually 4 times the area times area of a circle with the same radius. So that's surface area of sphere.